Hey guys, welcome to mean value theorem and Rolle's theorem lesson. So in this video I'm going to go ahead and just complete off the rest of the exercises that we have here. Example number 1, show that the conditions of Rolle's theorems are met and find the C that Rolle's theorem guarantees. So what are the conditions for Rolle's theorem? Rolle's theorem has 3 conditions. F is continuous on A to B inclusive. Second is F is differentiable on A to B exclusive on the open interval. And 3, F of A is equal to F of B. This is my A. This is my B. So let's go ahead and see, is this function continuous? This is the quadratic function. And from pre-calculus, you guys studied all your parent functions, and you know that quadratics are continuous and they're also smooth. So number 1 is good, number 2 is good. Now all we have to do is check if 3 is good. So that means check the endpoints. Does f of 2 equal to f of 3? And let's find out. Negative 2 squared minus negative 2 minus 6, and that gives me, 4 plus 2 minus 6, which is 0. So now let's see if f of 3 is also 0. So it's 3 squared minus 3 minus 6, which is 9 minus 9, and that is 0. So yes, Rolle's theorems, the conditions for Rolle's theorem are met. Now let's find the C that guarantees Rolle's theorem. So what does that mean? That means we have to go to the Rolle's theorem and find when is the derivative equal to 0. Very, very similar to finding the critical points, the critical numbers. So we're going to find the derivative of this function, 2x minus 1, and we're going to set it equal to 0, and x is equal to 1/2. This is my C. My C is 1/2, and I'm done. The next example utilizes MVT. Given the function f of x on the interval 1 to 5, the graph of f of x is shown on the right. Visually, what is the MVT trying to find? Draw it in. Well, from the theorem, we want to find when x, or shall we say C, when f of x derivative is equal to the average rate of change. That is what we want to find out. So let's draw it. We're on the interval from 1 to 5. That's my A to my B. This is 1. This is 5. 1, 2, 3, 4. This is 5. And all we have to do is draw 2 dots at these points, at these endpoints, and draw a secant line. Now, where do you guys think, what x value do you think the derivative is the same as the average rate of change? So I'm thinking maybe somewhere between 2 and 3. So I'm going to say maybe 2.5. Draw it in there. So we're going to go ahead and check. Well, I drew mine really wrong, but we're going to say that maybe at C equals 2.5. We don't know. We're going to use calculus to find out. So let's go ahead and use calculus. The mean value theorem says if f is continuous and differentiable on an interval, then there must be a derivative such that, there must be a C value such that the derivative is equal to the average. So we're going to use this little equation to help us guide us with this. Let's go ahead and find the average. What is the average of f of x from 1 to 5? you can do two things. You can plug in these numbers into your function, or you can use the graph itself, since we already have the graph. F of 5 is 2, f of 1 is negative 2, all over 4, which is 1. And it makes sense because look at my slope. It's rise 1, run 1, rise 1, run 1, and so on. So now what I need to do is find the c at which the derivative is equal to 1. So that means take the derivative of f, set it equal to 1. So f prime is equal to, well, let me go ahead and rewrite this as 3 minus 5 to the negative first, 5x to the negative first. So my derivative is 5x to the negative second. Finally, we set that equal to 1. 5 over x squared is equal to 1, which is the same thing as x squared over 5 is equal to 1. I just flip both sides and I see that I get square root of 5 as my answer. Well, not square root of 5. Plus or minus the square root of 5 is my answer. I have two answers, but which one actually satisfies my mean value theorem? Only the positive version satisfies it, because I'm only dealing with numbers in between positive 1 and positive 5. So my c is equal to the positive square root of 5. And positive square root of 5 is roughly 2.236 ... I don't know. Something like that. Pretty sure it's 2.36 though. We have time for some more examples. So it's actually our last example. So here's a pretty fun way of applying the mean value theorem. You are driving a car traveling on an interstate highway at 50 miles per hour as you pass a police car. So let's go ahead and draw a picture. So let's say you're at point A, you're passing point A, and point A is the first police car. 4 minutes later, you pass a second police car. Let's call this point B, and again you are traveling 50 miles per hour. So this is 50 miles per hour at point A, 50 miles per hour at point B. The speed limit is 60 miles per hour. The distance between the two police cars is 5 miles. So you're talking about a distance of 5 miles between these cars. The patrolman in the second police car gives you a speeding ticket for driving 75 miles per hour. How can he prove that you were speeding? So first of all, you traveled 5 miles in 4 minutes, which is the same thing as 4 over 60 hours, which is the same thing as 1 over 15 of an hour. Well, how do you find your speed over 4 minutes? You take the average of how much you traveled over the time. So remember that speed or velocity is distance over time from your physics class, and distance is 5 miles divided by 1/15 of an hour, which is the same thing as 75 miles per hour. So this cop didn't zap you. This cop was able to communicate with the other cop, and they were able to find out that you traveled 5 miles in 4 minutes, and cop B is apparently really good at mathematics, and he found out that your average speed from point A to point B was 75 miles per hour. So he gave you a ticket. Let's talk about the last problem. You foolishly argue with the patrolman who is writing your speeding ticket, and he calls his brother who is currently taking calculus and has just learned the mean value theorem. Ouch, bad news. Now the patrolman rewrites your ticket and charges you for driving 65 miles per hour twice during the 4 minutes. How can he prove this? Well, first of all, your average was 75 miles per hour. That could mean a lot of things. That could mean you could have gone to 80 miles per hour, even 100. But you slowed down just slow enough so that your average was 75. So if you attained 75 miles per hour, you must have passed 65 on the way up and 65 on the way down at least one time. Okay, so that means you traveled 65 up once and down, so you hit a total of two instances at which you traveled 65 miles per hour, which means you're getting 2 tickets because you wanted to argue with a cop.